Welcome. Today, our exploration takes us to the southern celestial hemisphere. We're not looking for the most brilliant, eye-catching constellation. Instead, we're focusing our attention on a much fainter one, Indus. And you'll see why. It may seem unassuming, but for the fields of modern astrobiology and cosmology, it is an absolute treasure trove of scientific data.
And that really gets to the heart of our analysis today. The profound importance of Indus doesn't come from the sheer luminosity of its stars. It comes from its closeness to us. Proximity is everything. This constellation is a next-door neighbor in cosmic terms, and that neighborhood is what makes it so incredibly valuable to science.
So, here's our roadmap. We'll begin with the foundational data, its astrometric profile. Then, we'll zoom in on the main attraction, the Epsilon Indi system. From there, we'll pan out to examine some of the deep space objects hiding within its borders. We'll also touch upon its unique mythology, or lack thereof. And finally, we'll cover some practical advice for observing it yourself.
All right, first things first. Before we can appreciate its scientific significance, we need to understand the fundamentals of Indus. We need to map its territory on the celestial sphere and, crucially, determine who on Earth can actually observe it. So Indus occupies a patch of sky measuring 294 square degrees. To put that in perspective, that ranks it 49th in size out of the 88 modern constellations. And within that area, under ideal dark sky conditions, about 38 of its stars are visible to the naked eye. Now, that might not sound impressive, but as we're about to see, with Indus, it's very much a case of quality over quantity. Now here's a critical constraint. Your ability to see Indus is strictly determined by your latitude. Imagine a globe. If you're anywhere south of about 15 to 25 degrees north, congratulations, you get a full unobstructed view. As you travel north into that middle band, it starts to sink below the horizon, and you can only see its northernmost stars. But if you're anywhere north of 45 degrees latitude, well, it's completely invisible, always below your horizon. It truly is an exclusive feature of the southern sky.
And now we arrive at the centerpiece of our investigation, the Epsilon Indi system. This, right here, is the primary reason Indus is on every modern astronomer's radar. At just 11.8 light-years away, this system isn't just close, it's one of the nearest stellar systems to our own sun. The primary star here is Epsilon Indi A. It's an orange dwarf, a K-type star. Now picture it next to our sun. It's smaller, cooler, and only about 3/4 of the mass. But what makes it so compelling is its incredible stability and longevity. These stars can burn steadily for tens of billions of years, far longer than our sun. That vast timescale provides an enormous, stable window for life to potentially emerge and evolve.
But it gets better. In 2003, astronomers discovered something truly remarkable orbiting the primary star, a binary pair of brown dwarfs. You can think of brown dwarfs as failed stars. They have more mass than a planet like Jupiter, but not quite enough to kickstart the sustained nuclear fusion that makes a star shine. This pair is scientifically priceless. They act as a sort of reference thermometer, allowing us to precisely measure and model how these substellar objects cool over cosmic time.
And this brings us to a breakthrough discovery from just this year, 2024. Using the James Webb Space Telescope, we obtained a direct image of a planet orbiting one of those brown dwarfs. We call it Epsilon Indi A-B, and it's an anomaly. It's a gas giant, similar in mass to Jupiter, but look at its temperature. Where Jupiter is a frigid minus 110 Celsius, this planet clocks in at a relatively balmy 2 degrees Celsius. This is completely unexpected, and it forces us to go back and rethink our fundamental models of planetary formation and thermal evolution. For the observers among you, here are the precise coordinates you'd need to pinpoint Epsilon Indi. With an apparent magnitude of 4.69, it's just bright enough to be seen with the naked eye from a truly dark location in the southern hemisphere. So the next time you have the chance, I encourage you to look for this specific point of light and appreciate the incredible scientific drama unfolding there. While the Epsilon Indi system is clearly the headliner, the constellation Indus has a few other fascinating objects within its boundaries. So let's broaden our view for a moment and look at what else is out there. Okay, the brightest star in the constellation is Alpha Indi, an orange giant sometimes called the Persian. But the real gems here are the galaxies. First, you have NGC 7049. It's a lenticular galaxy about 100 million light-years away. And what's stunning is the prominent backlit dust ring that encircles it. It looks like a great, dark, cosmic eye staring out from the void. Then there's NGC 7090, a beautiful spiral galaxy that we happen to see perfectly edge-on. It appears as a thin, elegant sliver of light, like a silver noodle adrift in space. So, we've covered the astronomy. Now let's shift gears and look at the history and philosophy behind this constellation. Unlike the ancient figures from Greek and Roman mythology, Orion, Hercules, Andromeda, Indus is a much more modern invention. It was born from the intellectual currents of the Age of Discovery.
Indus was first formally charted in 1598 by the cartographer Petrus Plancius. He based his work on the celestial observations of Dutch sailors who were charting new trade routes to the East Indies. But it was its inclusion in Johann Bayer's monumental star atlas, Uranometria, in 1603 that cemented its place in the heavens for good.
Bayer's illustration depicted a man holding arrows meant to represent a native inhabitant of the so-called New World. For the Enlightenment thinkers of the era, this image became intertwined with the philosophical concept of the noble savage. This was the idea of a person living in a pure, natural state, uncorrupted by the vices of European civilization. Placing this figure among the eternal stars was a symbolic act, a philosophical statement about a shared, universal humanity under one sky.
All right, we've explored the science and the history. Let's make this practical. You probably want to know how you can actually go outside and find this scientifically rich, philosophically interesting patch of sky for yourself.
So, the key is to have a dark location with a clear southern horizon. First, you want to find two bright guide stars, Achernar in the constellation Eridanus and Fomalhaut in Pisces Austrinus. Indus lies in the relatively empty, dark expanse of sky between them. Now, it's faint, but if you take a standard pair of binoculars, say 10 by 50s, and scan that area, you should be able to pick out the faint but distinctly orange glow of Epsilon Indi, that tiny point of light that holds such immense scientific promise.
Indus provides us with a profound lesson. The universe's greatest treasures are not always its most brilliant. Sometimes, the most transformative discoveries aren't in some distant, dazzling nebula, but are quietly waiting in our own cosmic backyard. As we continue our search for life beyond Earth, Indus reminds us to look closely at our neighbors. It leaves us with a tantalizing question: what other secrets are waiting just a few light years away?